Hi students, this is Sagar, and in today's class I am going to explain few questions from previous year Neet questions, and I have taken the first topic as haloalkanes and haloarenes. This is part 1 of haloalkanes and haloarenes. Let me start with the first question, which appeared in 2019 Neet paper. Okay, the first question is the hydrolysis reaction that takes place at the slowest rate among the following gains. Okay, this question based on hydrolysis reaction, and you can see the options given here. You can see the first option, we got substituted haloarene reaction with aqueous sodium hydroxide. So all these reactions, 4 reactions given with aqueous sodium hydroxide, or can take it as alkaline hydrolysis reactions. And if you see the substrate molecules, the first one is substituted haloarene, second we got ethyl chloride, third one allylic chloride, and fourth we got is benzyl chloride. And we already learned in haloalkanes and haloarenes that haloarenes are less reactive compared to haloalkanes towards nucleophilic substitution reactions. You can see here the first substrate molecule, I said only it's haloarene. You can see chlorine attached to sp2 hybridized carbon atom. In the case of second one, we got ethyl chloride, chlorine attached to sp3 hybridized carbon. Third one, allylic chloride, in which chlorine attached to sp3 carbon, which is next to the carbon-carbon double bond. And fourth one we got is benzylic chloride, and in this chlorine attached to sp3 carbon, which is next to the benzene ring. Okay, so only one point enough here to get answer for this question. Haloarenes are less reactive than haloalkanes towards nucleophilic substitution reactions. So the right answer for this question is the slowest rate they asked. So the right answer is first option. Okay, let's go to second question, which appeared in 2018 Neet paper. Okay, the question is the sequence reactions here. We need to find the last product. Okay, here it should be C. Let me read the question. The compound C7H8 undergoes the following reactions. Okay, the first one, starting with molecular formula C7H8. The first reaction you can see here, 3 moles of chlorine and in the presence of heat. So you can easily tell this reaction as a free radical chlorination reaction. Second one is bromine in the presence of halogen carrier Fe, and we can easily tell this reaction as electrophilic substitution reaction. And the last one is with the zinc and HCl, so we can take this as a reduction reaction. Okay, so they asked the product C here. Now first we need to get the structure of C7H8. Okay, let me see the solution part now. C7H8, at first, to get the structural formula, we can make use of the double bond equivalent. In a double bond equivalent we can find by using the formula. As you can see, first it contains 7 carbon atoms, and if it is completely saturated compound, we expect like CnH2n plus 2 formula, we expect totally 16 hydrogen atoms if it is completely saturated, but it contains only 8 hydrogen atoms. So the difference here, we expect 16, and we are having only 8 here, so 16 minus 8 by 2, so we'll get 4. It means in this compound with the formula C7H8, we'll be having 4 unsaturated groups. You can say, like it can be the combination also. It may be 4 double bonds, or we can take 3 double bonds, and a ring can also be taken. Okay, this gives a clue now. If it is 4 double bond equivalent, so you can easily guess now by seeing number of carbon and number of hydrogen atoms. So the molecule should be toluene or methyl benzene. So we have taken C7H8 now as toluene. Okay, starting with toluene, first reaction, as you already saw here, chlorination and presence of heat. Okay, so if you take 3 moles of chlorine here, excess of chlorine used in this reaction, and the reaction is free radical chlorination. So what happens now? The methyl group, we got three equivalent hydrogen atoms here, and all three hydrogen atoms are replaced by three chlorine atoms. So we'll get like trichloromethyl benzene. Okay, trichloromethyl benzene, that to be taken as A, as given in the question there. The second reaction is electrophilic substitution reaction by using bromine in the presence of Fe as a halogen carrier. Right now this is electrophilic substitution reaction, and on benzene you can see the group here CCl3. Okay, this CCl3 is an example of electron withdrawing group, and we already know what happens when electron withdrawing group is present and its orientation. So if you're having any electron withdrawing group present, so what it does now, that to be taken as like meta director. So what happens now, this CCl3 directs the electrophile Br plus to meta direction or meta position. So we'll get formation of meta substituted product here. Okay, this is structure of B. So we got formation of meta bromo trichloromethyl benzene. Okay, once you get this, the next step and the last step given in this reaction is reduction. Okay, now if we take reduction by using zinc and HCl, reduction, we can easily reduce the CCl3 group into CH3. So we'll get formation of meta-bromo-toluene. So that is the compound C given in the sequence reaction. So the right answer, so C should be meta-bromo-toluene. Okay, next one now. Third question. Identify A and predict the type of reaction. Okay, again reaction is given here. So first we need to identify what is this product A and which type of reaction is this. Right, you can see now we got di-substituted benzene. One group is methoxy group and another we got bromine. Right, let me take the reaction now. At first, the reagent used in this case is sodamide, NaNH2. NaNH2 dissociates to form NH2 minus, which is very strong base which can abstract proton even attached to sp2 carbon. Okay, so this is more acidic proton. So what happens in the first step, NH2 minus will pick a proton, and as a result the bonding electrons will shift between the two carbon atoms. So we got these two carbon atoms. Then oddly it's a doubly bonded, right? So what happens now, as a bonding electron shift here, so it becomes a triple bond, and bromine will leave in the form of bromide, Br minus. Okay, so this reaction we can easily call that's elimination, right? H plus is eliminating and Br minus, so we can take this reaction as elimination. So the first step in this reaction is elimination. Okay, the next what happens, NH2 minus, so as it is in excess always, will attack to the second carbon here. Right now we got two possibilities. Now it can attack on second carbon or it can attack on third carbon, but preferentially it attacks on second carbon only, as I have given here the reason for that. Okay, so preferential attacks on second carbon only because of, as you can see, the second carbon is close to the oxygen, right? And oxygen is more electronegative. It pulls electrons towards itself and it makes the second carbon more electrophilic. And NH2 minus is a nucleophile, so it attacks easily on second carbon or preferentially on second carbon. And the reactive intermediate what you got in this first step is called benzene. As you can see, we got a triply bonded here, right? C triple bond C. So we can call this intermediate as benzene intermediate. Okay, NH2 minus will attack on the second carbon, and as a result we'll get we can take like simultaneous, as it attacks on the second carbon and it abstracts a proton, results in the formation of the compound here, right? Ortho methoxyaniline. So you can see the structure now, orthomethoxyaniline. Okay, let's just see the options given here. We got option A, we got a methoxy group and NH2, right, in ortho position. So the right answer should be option A. And the reaction type they asked, so the reaction first we have taken elimination followed by addition. So the reaction should be elimination addition reaction. So the right answer is option A. Next one, consider the reaction. Okay, so again a reaction is given here and the question is, this reaction will be fastest in which medium or in which solvent? Okay, just see the reaction there. CH3 CH2 CH2Br plus NaCN, sodium cyanide, results in formation of N-propyl cyanide or butane nitrile. Along with that, we'll get formation of sodium bromide. Right, if you see the reaction now, as you can see, the alkyl halide used in this is N-propyl bromide, and it's an example of primary alkyl halide. And we already know primary alkyl halides will undergo hydrolysis reaction by SN2 mechanism. So first we need to identify here which type of mechanism it's undergoing the reaction. So it's undergoing reaction by SN2 because it is primary alkyl halide. And if it is SN2, you know the solvent type. Okay, in SN1 it's favored by polar protic solvent, and SN2 is favored by polar aprotic solvent. And you can see the options given here. We got ethanol, methanol and water. So these three are polar protic solvents. Only one option there, that's N-dimethyl formamide or DMF, is an example of polar aprotic solvent. So as it is SN2 mechanism, so we need polar aprotic solvent like dimethyl formamide. So the right answer for this question is option C. Okay, next question now. Two possible stereo structures of, okay, a molecule is given here. You can see CH3, CHOH, COOH, which are optically active are called. Okay, so optically active two stereo structures, we need to guess what do you call those structures. Okay, by seeing structure, it's one thing clear. This carbon is chiral carbon, right? Because it's attached to four different groups here. Methyl, we got one hydrogen, one hydroxy and a carboxyl group. Okay, COH. And if it's having one chiral carbon atom, so it should be having two structures, right? There should be object and its mirror image, and the two structures which are related as non-superimposable mirror images are said to be enantiomers. So the right answer for this question is enantiomers. Okay, so this is about the part 1 of haloalkanes and haloarenes. So the next question I'll be adding to the next parts. Okay, so if you like the video, please subscribe to my channel.